the new boards in. They actually look pretty good. Much more copper surface area than the previous ones. There was a minor problem with this one, though. So apparently the labels that got printed out for these two components here, which happen to be C4 and R1, when you're looking at the board, they look like R1 should go down at the bottom, C4 should go up at the top. That's actually not the case. They should be reversed. I'll be shipping out a PCB layout schematic so you know where things are supposed to go. The board will still work otherwise, even if you reverse those components. The only thing that will happen is the LED won't light up. So that's been fixed in the Gerber file, and the next time I go to do a production run of these, that will be fixed. But anyway, I figured we'd take a look at the board real quick and then do some load testing on the new version, make sure that it can indeed handle 3 amps. The other cool thing is I got a little logo on here. Let's see if I can get that in focus. Anyway, it's a little Viking with a beard, looks kind of grumpy. So yeah, I thought that was kind of cute. I'll take it. So anyway, we'll get this other guy hooked up real quick. And have to do this off camera, unfortunately. These wires are stiff and it just pushes it off the frame there. So, but as we can see, let me pull this back down in here. There we go. Okay, so you can see we're at 5.06 volts, which is what we were at on the last test. Oh, I should bring up. Yeah, it's okay. I don't remember exactly what the power supply was set at to begin with. I think it was 9 volts. So we'll try that here and see what happens. Actually, I'm going to consult that spreadsheet I did earlier. Give me just a second. I'll be right back. Okay, so I've consulted, and yes, we were at 9 volts. So I'm setting my input power supply to be 9 volts exactly. And we're almost there. Okay, so we're at 9 volts there. You can see the buck converter is set to put out 5.06 volts here. So now we're going to crank this up and see if we can actually get to the 3 amp limit that I originally designed this for. And then if we get to the 3 amp limit, then I'll do the readings on the input power supply and the output, and we'll get an efficiency at full load and see what happens. So we're going to crank this up a little bit. Alright, so at this point, we're at 1.3 amps, and you can see the voltage still hasn't sagged, so we're already doing better than the previous revision of that board. We'll take this up a little higher. Go to 2 amps, 2 1/4, 2.5-ish, 2.9. Holding 3 amps, and the voltage still hasn't sagged yet, so that's good. So looking at the input supply, we've got 9 volts at 2.07 amps, and then we're at 5.06 at 3.06 amps. Let's see how high we can go before this starts to sag. Yeah, 3 1/4. Been pretty good. Nice. We're almost at 3.5 amps. That's much better than what I thought. Good deal. I'm not going to push it past that. So we got 3.5 amps out of that. I am extremely pleased with it. Let that chip settle down and see if it drops back down to 5.06. And feeling the buck converter IC, it's warm to the touch, but I've had my pinky on it for about 10 seconds now, and I can still hold it there. So I got a funny feeling that yeah, it settled down and it's going to drop back down to 5.06. So yeah, I'm pretty happy with that. So let me pause this again, and I'll bring up the spreadsheet that we did on the efficiency, and we'll review that real quick. Hang tight. Okay. So yeah, here's the original spreadsheet that I had done. So we'll pop in the new numbers for the 3 amp range. So input power supply was 9 volts. We had 2.07 amps on that. The buck converter output voltage was 5.06 and steady. The current was 3.06, and interesting. I did not expect that. I didn't expect the efficiency to drop, but it's still okay. Like I said, when I was going to school, if you were hitting 70 plus, you were doing pretty good. So 83% efficiency, again, I will take that. And quite frankly, for the microcontroller stuff that we're going to be doing, unless the motors are going to be kicking in, it's not going to be under such a heavy load. So I suspect that you know, it's going to operate in a higher efficiency range. So that's this week's update. I don't know if you can hear it behind me, but the 3D printer is kind of doing its thing. I've had a heck of a time with that this weekend. I've been doing a lot of design on the medication dispenser mechanisms, and I've been putting the 3D printer through its paces, and it finally threw up its hands last night and said, "I'm done. Forget you guys, I'm going home." So I'm limping through printing out a new filament drive for that now. And then hopefully we'll get back up and running. Updates for the next video. So I've got the microcontrollers in. I have to see if, here we go. Yeah, I'll bring this in shot here real quick. I'll flip over to, well, maybe I won't. Hold please. Okay, so I've definitely got a let me move this load tester out of the way here. So I've definitely got a learning curve going on with this bunch here. So I've got an original Arduino Uno that I was using to try to boot load this chip. It's not going very well, so I'm going to have to order an AVR ISP programmer. Or if you guys know what I'm doing wrong, please let me know. But anyway, that should be like $10 or $15, and I won't be able to order it for a week or two, but we'll get that in, get this microcontroller processed, and then we'll just kind of go from there. So things are starting to come together. It's just a little slower than I would like. We'll catch you guys in the next video. Have a good one, and be safe out there.